All right, let's just jump right in. We are absolutely swimming in data. It's like this massive digital ocean. And deep down, hidden beneath the surface, there are these incredible secrets and stories and patterns just waiting to be discovered. So today, we're going to gear up, become data detectives, and learn the techniques to pull those patterns into the light.
I mean, seriously, think about it for a second. You finish binging a show, and boom, the next recommendation is weirdly perfect. How does it do that? Is it a psychic? Just a lucky guess? No. The real answer is way cooler, and it's the perfect mystery for us to solve today. Well, it's not magic. Not at all. The secret is a really powerful data mining technique called market basket analysis. And it's a classic for a reason. It's all about finding associations between things, whether that's movies you watch, songs you stream, or, and this is the OG example, the groceries you toss in your shopping cart. Now, if we're going to be a good detectives, we can't just wander around guessing. We need a tool belt, right? A set of specialized tools to figure out how strong our clues are. So let's look at the three most important metrics in our detective kit. First up, we've got support. And honestly, this one's super simple. It's just a popularity contest. How often does something show up? The support for milk is just how many shopping carts have milk in them. It tells us how common an item is, or even a group of items, which we call an item set. Simple as that. Okay, tool number 2 is confidence. This is all about the if-then game. It measures how reliable a rule is. So if someone buys peanut butter, what's the probability, what's the confidence that they'll also buy jelly? This gives us a hard number, telling us how often our hunch is actually right. And last but not least, we have lift. This one is so important. It's kind of the reality check for our rules. It tells us if our discovery is actually interesting or if it's just a coincidence. See, if the lift is greater than 1, it means these two items are bought together way more often than you'd expect just by random chance. It's the clue that tells you, hey, this is a real pattern. Okay, so we've got our tool belt, but imagine trying to use it on millions, literally millions of transactions. You can't just check every single possible combination, you'd be there forever. That's where a really clever systematic method comes in. It's a classic algorithm called Apriori. Think of it as our detective's master plan for sifting through all the evidence efficiently. Now, the secret sauce that makes Apriori so powerful is this one brilliant idea. It sounds a little academic, I know, but let me break it down, because it's actually super intuitive. All it's saying is this: if lots of people are buying bread, milk, and eggs together, well then it's impossible for that to happen unless lots of people are also buying just bread and milk. This simple piece of logic is what lets the algorithm take massive shortcuts. So here's how the process works. It's really smart. First, it just finds all the individual items that are popular on their own. Then it pairs those up and checks which pairs are popular, throwing away any that aren't. It just keeps repeating this join and prune dance for bigger and bigger groups, quickly zeroing in on the most important patterns without wasting any time. All right, let's make this real. Forget the theory for a second. This table right here, this is our crime scene. It's a tiny little database with just 9 transactions. Each row is one shopping trip, and the items are just labeled I1, I2, etc. This is the raw evidence our a priori detective is going to work with. Okay, step 1. The algorithm does its first pass over the evidence. All it's doing is counting. It's just counting up how many times each individual item appears. Now, we have to set a bar, right? Let's call it the frequent enough bar, our minimum support. We'll say it's 2. Since every item here shows up at least twice, they all make the cut. They all get to move on to the next round. Now for the clever part. The algorithm takes that list of frequent single items and starts making pairs. It joins them up into every possible combination. Then it scans the data one more time, but now it's counting the pairs. And again, using our minimum support of 2, it keeps only the pairs that are frequent enough. This whole join and prune process just keeps going until there are no more combinations left to find. Okay, so everything we've talked about so far is about finding rules. If this, then that. But what if you don't even know what you're looking for? What if the mystery isn't about rules, but about finding the natural, hidden groups that exist in your data? Well, for that, our detective needs a totally different approach: clustering. So let's just put these two side by side. Association rules are all about finding recipes, people who buy bread also buy butter. Clustering is more like sorting your customers into different types of shoppers. It's not about finding a rule, it's about finding a group, a profile. Like, these are my budget-conscious shoppers, or these are the weekend movie watchers. The official term is cluster analysis. And the goal is actually really simple when you think about it. You want everything inside a group to be as similar to each other as possible. And at the same time, you want the groups themselves to be as different from each other as they can be. You're looking for tight, well-defined groups. So, just like before, our detective has a few different profiling techniques in their kit. There are a lot of ways to do this, but we're going to check out 3 of the big ones, the most popular methods for finding these hidden groups. First, we've got k-means. This one's a classic. It's super fast, super efficient, a real workhorse. The only catch? You have to tell it ahead of time how many clusters you're looking for. That number is the k in k-means. So it's perfect when you already have a target in mind, like, I want to find 5 distinct customer segments. And how does it work? It's actually a pretty cool little dance. It starts by randomly guessing where the centers of the groups are. Then, every single data point gets assigned to whichever center it's closest to. But then, and this is the key, the algorithm finds the new middle of each of those fresh groups and moves the center there. It just does that over and over until the groups stop changing.
Okay, but what if you have no idea how many groups are in your data? That's where hierarchical clustering shines. Instead of making you choose one number, it builds this beautiful tree structure called a dendrogram. You can see how individual points connect to form small groups, and how those small groups merge to form bigger ones. It's like a family tree for your data.
And our last profiling tool is called DBSCAN. This one thinks about things differently. It doesn't look for centers. It looks for crowds. It basically says a cluster is just a dense little neighborhood of data points. And the coolest part? It's amazing at finding clusters that have weird shapes, and it's brilliant at spotting the loners, the outliers, the data points that just don't fit in anywhere. So we've been through association rules, we've been through clustering, a bunch of powerful detective techniques. But here's the thing, this isn't just some abstract academic exercise. These are the engines running quietly in the background of the world around you every single day. Let's bring this all back to reality. Remember that streaming service we started with? That's market basket analysis. Ever wonder why the chips are always near the soda in the grocery store? Not an accident, that's market basket analysis too. Companies use k-means to figure out their customer segments. And DBSCAN, with its knack for spotting the weirdos, it's perfect for things like finding credit card fraud. The applications are everywhere, and they're huge. So when you boil it all down, the big takeaway is this. It's not magic, not even close. It's a logical, repeatable process for finding answers that are already sitting right there, hidden in the data. You just need the right tools and a good detective to uncover them. So the next time you get a recommendation that's just a little too perfect, or you see an ad that knows exactly what you've been thinking about, you'll know. You'll know there's a data detective on the case. And that leaves us with one final question. Now that you know the method behind the magic, what hidden patterns are you going to start noticing in the world around you?